Hi, this is Kilo Mike 4 Zulu Kilo Bravo Jerry, and I went and did something this weekend. I went to the Huntsville Ham Fest and I bought a fiberglass mast. I normally don't buy things, but I thought I could make a good antenna out of that. And what I'm going to start with is a vertical antenna, a clone of a DX Commander type multi-band antenna. So stick with me. We're going to do a little fabrication and then we're going to try to get this thing up in the air. Ought to be a lot of fun. Okay, we've got most of our supplies laid out here. I bought 2 pieces of aluminum from the local metal shop that were drop pieces. He sold it by the pound. This one is pretty thick. It's about a quarter, it's 3/16 I believe. This is 3/16 of an inch, and I'll put the metric on the screen later. And this one here is 1/8 of an inch. Gonna model this after the DX Commander. Callum has done a fantastic job with those, but even though his antenna is not that super expensive, I like to build stuff myself, and anytime I can, that's what I hope to be able to do. So I've already got these cut out. This is going to be our ground plate here, and I'm going to drill the hole for the SO239. Will fit approximately here, and then we'll have our ground connections around the edge here. This is about 10.5 inches square. It probably doesn't need to be this big. This is what he had. And all I did was cut out right here to have the tab to connect the SO239 to. And it, you know, like I said, I'm modeling after what Callum did. It's not going to be exactly like it. It's going to be my spin on it with the materials that I have. And I went looking for stainless steel nuts and bolts, and I went to the local farm store and then the big box stores, and they were 90 cents a piece just for the bolt. And these are 1/4 inch diameter, 1 inch long, and I got 2 nuts for each so I can lock them to the plate. As I was leaving the first store, I was talking to the clerk, and I said, you know, these stainless steel bolts are just super expensive. And she kind of leans over and says, have you tried the local industrial supply store? And she gave the name of it, and I said, I'm not even aware of it. You know, I've only lived here 4 years, and I wasn't even aware of this store. And she told of a store where I could buy these bolts, get them cheaper. I picked these up for 20 cents a piece. Now they're stainless steel, and I got the washers and the nuts to go with it. And here is the invoice, and I got 20 of the hex cap screws, and 40 washers and 40 hex nuts. $10. It would have cost me so much more. But we're going to be marking out the holes, and I'm going to be cutting a hole in the center here for the mast. And the mast is approximately 1.9 to 2 inches at the base. I'm going to cut a 2-inch hole in the center here. And to find the center, I just took a straight edge and went corner to corner, and where they meet in the middle, that's the center. And I'm going to cut a 2-inch hole there, and then we'll drill holes for the radial connections, and I'm going to be putting I'm going to start out, I'll say it this way, I'm going to start out with 16 radials. I'll probably just put one in each corner and have 4 going out from it, and that should be more than sufficient. So I'm going to go ahead and start cutting holes and do the same thing here. This will be the driven plate, and that's where all the vertical driven elements will be connected to this. This one will have a little bit more stress on it from the shock cord, but with this being 3/16, I think that would be about the equivalent of 4 mils, I'm guessing, and this is probably 3 mils. Going to start drilling some holes and cutting a hole in the center here, and we'll come back after those are cut. Okay, not the prettiest hole in the world, but it fits. Fits right over the end of the mast there, and I'll be using pipe clamp to secure it in place. And what I've determined I can do is put heat shrink tubing over the pipe clamp to help protect the mast coating there. I pre-tested a couple of pieces on here just to see how it would work, and I'm using what they call half-inch diameter heat shrink, and I unscrew this and just slip it over the end and heat it up in place. And this is the marine grade, and it has the glue in it, so you just slip it over like that, work it around, and then just shrink it on there like that. Let's get the heat gun out here. And they had a little discount on the mast. Plus, I don't have to pay for shipping since I bought it there at the Ham Fest. That saved $20 or $30 from shipping, and they marked it down $10 from what it was regularly. So there's how it heat shrinks onto the water hose clamp there. I think some people call them Jubilee clips, but water hose clamps, what I've always called it, the screw type water hose clamp. And I'll put another on there. We'll see how this fits. Get it out here, don't have to have it on the mast while I'm getting the screw clamp started. I ought to get the nut driver, since it's a lot easier to stay on the thing with a nut driver instead of a flat screwdriver. But it started there, so I need about another inch of the heat shrink, and there's a piece there that'll work. So I'm going to go ahead and drill some more holes around the corners here, and also drill a hole for the SO239. And then once we've got that drilled, we'll bend this up and figure out what we're going to use for a spacer here to keep these two separated. Only needs to be about an inch or so, and I think I probably have a piece of PVC that I can cut to length. I've got PVC left over from other projects, so let's get some more holes drilled in this, and then we'll get back on it. Okay, we've got our 4 corner holes drilled. We've got the hole drilled for the SO239. I need to drill a couple of 2 or 3 or 4 holes through here to screw the SO239 to the plate. Got the SO239 mounted, as you can see there. I've just used 2 screws to hold it in place. That should be sufficient, and all we have to do now is solder our center conductor wire that will connect to the other plate. I haven't drilled the other plate yet. Just doing one at a time, trying to make sure I do it right the first time, and that would be usable here. But we've got the 4 corner holes drilled where we'll attach our radials, and we can come back later and drill more holes if we want to attach more radials. You know, 16 is good, 32 is better, 64 is better. How many do you want to put out? I'm going to start with 16 to test the concept. Let's go ahead and drill some more holes. I'm going to bend this at a 90-degree angle. Actually, it'll go this way because we want this facing in the SO239 connector facing out, so it needs to go up this way. So we'll bend that 90 degrees. We'll do the holes in this other plate similar to this one, plus at least one more, and let you see how we do that. And all I'm using is regular drill bit. I drill this out as big as I could, and then I used a jigsaw right here. I used the jigsaw to cut it out, and I got it close, and then I used a file to smooth it out a little bit. So it's a multi-step process. It took a few minutes, not that long. You can use a regular wood bit on aluminum. This one is 8 teeth per inch. You know, you can see that there. It's 8 teeth per inch. It cut it very good. You just take your time. Let the blade do the work. Don't try to force it. Just let the blade go through it, and it cut very well. And you can buy a hole saw. I mean, if you want it perfectly round, a hole saw is another option, but it's an added expense. I'm trying to keep it cheap. The aluminum itself was, to me, expensive enough, and hopefully you can find another source. You may have some old, you know, I looked for cake pans, I looked for cookie sheets. As long as it's single thickness and at least 1/8 of an inch, it should work fine. You know, used to you could buy that stuff at a dollar store, but dollar stores aren't dollar stores anymore, as you are well aware. But I did get this at scrap price. I just basically bought it by the pound, and $18 for both pieces I thought was a good deal. If you priced it on Amazon, you could do a little better, maybe, depending on whether or not you have to factor in shipping. But hey, it is what it is. I wanted it today, so I may have paid a little bit more than I had to, but still, we're going to have a good working antenna here shortly. Stay with us. Okay, I'm going to show you how to find center on this. Like I said, you just take a straight edge, go from corner to corner, line it up, take you something sharp, or you can use a pencil, but I just prefer, since it's aluminum, it's easily scratched, and draw a diagonal on it, and then turn it and do the same thing again. And where they meet, that's the center. Hopefully you can see that there, but where they meet there, and where the two lines cross, that's the center of that rectangle. All right. So now what I was going to do is line this up over the top of it. And just visual, I'm not going to measure exactly, but your eye tends to make it in the center. I mean, line it up in the center. It looks equal all the way around. I'll take the marker, draw the circle, and then I'll cut it out, just like I did the other one. So hang loose. Be right back. I'll have the center out of this. I'll have the connection point here, so that we'll have a wire that will come to here, so I'll drill an extra hole right there, and then I'll put a hole. Oh, I think we need about 6 holes maximum. Some use 5 or 6 depending on the number of bands we're going to try to make it resonant on. So we're going to need 6 holes plus the 7th hole here, and I'll have to figure out how to get 6 holes equally spaced around this square. See what we'll come up with here in a minute. Be right back. Okay, we've got our plate drilled. I did this finish to it. You put a wire brush into the drill press, and you just lower it down, let it spin a little bit, and it cleans the aluminum, plus it gives it a little design, plus it hides any scratches or anything that's in the aluminum. So I did figure out how to do 6 holes, plus I did 2 others. I actually had a protractor, and 6 into 360 is 60 degrees, so I did a hole every 60 degrees. Plus I did one where we can connect the driven element to it. I was going to put it over here, and I decided to put it over here, and I know what differences make, probably none, but that's the reason it's got 2 holes. And it was a little more difficult to get this hole in there because this is 1/4 inch thick, well, about 4 mils thick, and it's a little bit stiffer, a little harder to work with, but it fits, so that's the main thing. So we've got that. Like I say, this is the driven plate, this is the radial plate. So we're going to put bolts through, and I didn't thread it. You know, if you got a tap, you can tap it. I don't see it as it's really necessary. I'm going to just tighten up these bolts here, and then put 2 washers on, and then another bolt, and that'll be where we connect our radials all the way around here. I'm going to start measuring out wire. I have a black wire. I'm pretty sure I don't have enough of any one color to make all the radials. Is that going to be a problem? No. I've got blue, I've got purple, I've got black. Plus, you know, once they're put down into the sod, it's not really going to make that much difference, because the grass is going to overgrow, the dirt and leaves are going to accumulate over the top of them. They're not going to be that visible. So a dark color will blend in, and the wire I'm using is a wire I've got. I've had this wire, I don't know how many years, 10, 15 years. I don't remember where I got it. I'm thankful I have it, but I don't remember where it came from. So I didn't have to purchase this wire, and so that cuts down on my costs. So, you know, I encourage you to use what you've got. This is just regular electrical wire. I believe it's THHN is what they call it. And this looks like it's maybe 16 gauge, which is, for radials, it don't really make that much difference. Just get it down there. Now the driven element, I'm probably going to use 12 or 14 gauge, a little bit thicker. Even though I only run 100 watts now, I may run more power later. So use the largest that I've got for the driven elements, and we'll go from there. But I'm going to measure these out. I'm planning on making my radials 16.5 feet each, and make them up, and we'll get them going. Okay, after looking at the wire diameter and the terminal itself, 2 wires is what's going to fit inside each one. So I've got this one crimped on, and I will solder them when I get through. But I've cut the radials 16.5 feet long, and this can be a tangled mess, and I'm going to have to figure out the best way to handle these. But that's the first one, and we'll have to make 8 more of these in order to have 16. So got a lot to do, and I don't think y'all want to watch me make each and every one. They're all going to be like this, two wires in each, and they'll be attached there, and I'll put two on each corner, and then I'll snug it down. I'll put it in between washers and nuts, and again, this is stainless hardware, so it's not going to rust. So I got to get busy and make a bunch more radials, and then we'll deploy this thing. Okay, gonna solder on these terminals here. Hopefully the soldering iron is hot. I've had it plugged in for a couple of minutes. Yep. Yeah, I think you can see this. Heat up the wire and the connector, and feed in the solder from the other side. Put a little solder on it just so it can conduct the heat better. The iron must not be very hot. I do have a fan running, and you've probably heard that going in the background in the video. It's 95 degrees outside here. I do have a small window air conditioner running and a fan blowing, but I'm not sure that's even enough. And we're getting some solder flow here now. But I was going to say the fan probably makes it a little harder for this small iron to heat up this joint here, because the fan is blowing on it. I think I'm going to have to get my old faithful, the soldering gun, old Weller, because it'll heat it up and it'll get it done quick. I don't have the patience to wait for this soldering iron to do it. This is one that's geared more towards a printed circuit board than it is heating up these 14 gauge two 14 gauge wires and this terminal connector here. So back in a minute. Okay, that didn't take long, did it, for you? Get this bad boy heated up here and get some solder to flow. Yeah. Now we'll get a solder joint. Yes, sir. I'll have to scrape the flux off of this connector once it cools, so it makes sure it does make a good connection. But that's that's a good solder joint there. All right, there's one of the 8. I did have to use a different wire for 2 of these. It's purple 14 gauge. The other is black 16 gauge. And it's not going to make a difference. Mix and match. I can spread them out. It don't matter. And we'll solder the other 6 pairs. And then tomorrow, because it's getting late in the day here, tomorrow I'll see about making some strain reliefs to go over the fiberglass mast, because we're going to have to guy it off, because it's going to be tall. It's just going to be sitting on the ground. We're going to have at least 3 guy ropes on it, and we'll guy it off probably at 2 different levels, probably around 8 or 10 feet off the ground, and then another 8 or 10 feet up we'll guy it again. And I'll have to make some little pieces, plastic standoffs that will fit down over the pole, and we will use more of these and we'll put heat shrink on them, and we'll put these on the pole to keep the plastic from sliding down, also to keep the pole from collapsing on itself. So that's the purpose of these clamps, and hopefully we've got enough clamps and we've got enough material to make all this work. Get back on it tomorrow. Okay, we're back in the shop. We're going to continue the build on the Poor Man's DX Commander, and I don't really know how much this is going to cost yet, but you know, I've got the pole. I paid $150 for the pole, no tax, no shipping, because I was at the Huntsville Ham Fest. You could probably may be able to get cheaper poles. This seems to be an excellent pole from what I can tell. Time will tell, and if I find out something different, I'll let you know, because I don't want you to make a mistake. If I make a mistake in a purchase or doing something, I'm going to try to correct it and let you know about it. Yesterday we completed our driven plate, and it's ready to go on the pole. I've got a clamp that's ready, and this clamp got heat shrink on it to help protect the pole. And I've taken the plastic end cap off of the pole. It just pulls off, and I'll put this on and just leave it loose for right now, and then we'll place the driven plate over, screws face up, and now we have a spacer. And this is just a scrap piece. You know, I use what I've got, but I had some 2-inch PVC conduit, and you could pick up a piece of this, go to a construction site, or you can go down to your big box store or your hardware store. You may be able to find a 2-inch piece, but it slips very snugly right over the end there, as you can see. And I'm going to use this for the spacer between the ground element here where the radials attach and the driven element here, to keep them from coming together. All right, and that's about, what is that, 1.5 inches, thereabouts. There's my tape measure. Use a micrometer, but it's about 1.5 inches. I just cut what looked right. I didn't even measure it. I said, well, 1.5 inches should be fine. And you know, it comes in close proximity to the center conductor, but that's okay, because this is what the center conductor is going to connect to. So, you know, if it comes in proximity to it, it shouldn't be an issue. So the other thing I did since yesterday, after I stopped taping, is I decided to cut the corners off of the driven plate here. Main reason, I didn't like their proximity to where the radial's connected. Just a personal choice. I don't think it would have been an issue, but I wanted the corners cut off, so I cut them off. Okay. Now what I'm going to do is I'm going to take the other clamp and put it on here. I prepared a second clamp. I'm going to take the other clamp and put it down here, just above. Let me see if I can turn this where you can see it. Just above where the plastic cap covers up here. Plastic cap goes on like that, and so I'm going to put that clamp there, and that'll hold the radial plate in place. And I went ahead and got my socket because it's so much faster than using the flat bladed screwdriver. I use the flat bladed screwdriver, you know, to do a test fit, but this just fits right over. And the socket size, what is that, a 5, well, this is metric. This is 8 millimeter. 8 millimeter, and I think the other one is a 5/16 in SAE. But that'll hold that. And then you push all this together. Just put a little pressure on it. It doesn't take a lot. And then you tighten up the other clamp. I'm going to stand this up. It'll make it easier to tighten this down because gravity is going to help me hold the plates together. Manhandle this thing. Get this snugged down now. The ratchet doesn't seem to be wanting to work right this morning. And just snug it down. It don't have to be super tight, but as you can see, it's on there now. All I have to do is connect this wire to this terminal here, and that's what's going to connect the center of the coax to the driven element here. So I'm going to lean this a little bit so it doesn't want to stand up by itself. Put a couple of washers on here. Don't know if they're required or not. You know, sometimes it seems to me that it makes better contact when you use the washers rather than just the nut. But that could be just the way I'm doing things. I don't know. So we'll tighten this up, and that's on there good. Going nowhere. All right. So now we've got our base unit. We need to make our standoffs for the driven elements and also for the tie-off points. What I've come up with is another cutting board. I can get 3 6-inch standoffs out of this one cutting board. So that's what I'm going to do. This is plenty rigid. You know, even at full length, it's hard to bend or deflect. So a little 6-inch circle is going to be rigid enough for these standoffs and also for the tie-off points for the guide wires. So I'm going to cut these out, and then we'll come back and determine where they need to be placed on this, and then I'll have to cut the holes to match the diameter of the pole where they're going to sit. And we'll be putting clamps underneath them as well to hold this up, as well as to keep the pole from collapsing in on itself. So I'll be back after I get these cut out, and I'll go ahead and drill 6 holes in them where the driven elements and the cords will be going through. Okay, I've got our 3 spacers cut out here. Drill the holes for the driven element wires to go into, and also where the shock cords will go through. So to do them all three the same, I'm going to drill all three of them at the same time. And I've found the approximate center of this disc because it's about 6 inches in diameter, and I have just gone around and measured 3 inches from each side and come up to an approximation of where the center is right there. Not precise, it doesn't have to be precise, but close. So now what I'll do, in order to get the holes for my 6 elements maximum, I don't know if I'm going to use all 6 or not, but I'm going to place the center of the protractor on the center of that, and then I can mark here at 0 degrees, 60 degrees, 120 degrees, and 180. Okay, now I just flip it around and do the same thing here, lining up with my previous marks for 0 and 180. Just have to do 60 and 120. So there's where our 6 holes will go. Now I also need 3 larger holes for our guys. So I'll put those here. I'll put one there, and I should be able to split these two, and they'll be 120 degrees apart for 360 degree guy. So we've got here, here, and here for the guys, and then there for the elements. I'm going to clamp these together and drill them out, and I'll come back and show them to you. Okay, we've got 3 identical spacers, and I have yet to determine what the size of the center hole should be. They will all 3 be different sizes because the mast is tapered as it goes up. The lowest one will be a larger diameter hole here than the upper one, and I've got to measure those and then cut the holes. So we'll see how that goes, because I have some hole saws, but I don't have that many. I know I won't have the exact size that I need, so I'll probably have to drill a smaller hole. I've got some round files. I should be able to round it out enough to where it will fit. It can be a tight fit. You don't want it a loose fit, even though I'm going to have the clamps underneath it. Still, it's going to be I need to get it as tight a fit as I can. So I'm going to extend the pole, and since it's I don't know exactly how long the pole is. I think it's 10 meters, but I need to extend it fully, measure it, and see where the joints are, and see where the best places to put the clamps for the guys and the standoffs are going to be. So I'll do that and get back with you here in just a minute. Unfortunately, I lost some important video while I was building the antenna, and that's on how I determined the size of the holes for the standoffs or the spacers. For some reason, that file got corrupted, only that one file. And so I'm going to try to recreate it, simulate it with this PVC pipe. And if you can imagine here, this is the larger of the 2 pieces. Okay, so this is coming up from the base, and the other piece fits into it. Okay, so that's how it looks. So this is towards the base of the antenna, this is towards the top of the antenna, and this diameter is smaller. And how I measured it was using a caliper. You don't have to have a caliper to do this, but I'm going to show you how I did it. So just turned on the caliper, and I measured right above the joint where the 2 pieces go together. And that told me the diameter that I needed for the hole, because I wanted the hole big enough to where the piece can slide down over the top, but stop when it gets to the joint. And you say, well, how can I measure that if I don't have a caliper or anything like this? Well, you can use just a regular measure. What you would do is you would collapse this section down into the base section, okay? And then the smaller sections would collapse down into this one. So you want it collapsed down, and then you can take and measure across the width of the section right here. You know, all the other sections would be collapsed down into here. You'd have it just barely pulled out of the base section, the section you want to measure. And you just measure across the diameter like that. And so you don't have to have a caliper to do it. But these are relatively inexpensive, and they come in handy for measuring lots of things. You can get them on eBay or Amazon. I'll have a link to one on Amazon if you want one, if you don't already have one. But they're good for precision measurements. And I use mine all the time for many different projects. But, you know, $15 or $20, you can get a decent digital caliper like this one. For hobbyists, these work fine. You know, just measure across the outer diameter like that, and that's the size hole that you need. Now, how did I make my holes? Well, you see here, I've got a selection of tapered bits, even up to a big one here. This goes up to 1.36 inches. So it's still not big enough to make the hole, but I happen to have a hole saw. These, you can buy them in kits, and these are not, you know, specifically made to cut plastic, but they'll cut wood, they'll cut plastic, they'll cut metals. They're very handy. I know I may have an advantage because I've had these for other projects in the past. You know, if you're building this from scratch, you may have to do it another way. And another way, I've used a saw. You know, cut like I did for the aluminum, cut a small hole, or as big a hole as you can make with this. Draw you a hole on a piece of plastic of the diameter that you want. Drill a hole in the center of it, and then use your jigsaw to cut inside the line that you drew. And then you may need to take a file or some sandpaper. Sandpaper will work on this plastic. You know, once you get it close, just stick the sandpaper in the hole, sand it down, and you should be good. It may take you a few minutes longer to use the sandpaper to get it smoothed out to the size that you need, but as long as you get it to the right size, you're not going to remember that extra 5 minutes later on. Use what you've got. You know, I've been blessed. I've accumulated these things over years. You know, this is not artificial gray hair. I didn't get all this stuff at once. And I realize that some of you are starting out and you may not have it, but tools are an investment. And I've saved myself tons of money over the years by having tools. You know, I may have bought a tool for one specific job, but I've used it for many other jobs over and over and over. So that tool has paid for itself more than once. So tools are an investment. You don't have to buy them all at once. You know, if you have to buy something, buy it for that project. You know, it may not pay for it on that project, but you're going to continue to use it over the years. And that's what I've learned from my experience. And that's how I've gotten most of these things that you see here. is I didn't buy this stuff all at once. You know, these are cheap. I picked these up down at Harbor Freight. They're not the highest quality, but for the hobbyist, they're going to get the job done 99% of the time. And so if you haven't got the tools, make do with what you've got. You use your jigsaw. It doesn't have to even be an electric jigsaw. You can use a hand saw. There's more than one way to do this. As I said, there's more than one way to skin a cat. Use what you've got. As I like to say, you know, when you're cutting holes into plastic or whatever, and you don't have the exact diameter that you need, what I call is sneak up on it. Get it close but undersized. And then you can polish it out, sand it out, rough it out with a file. There's lots of different ways to do this. Be creative. Think about what you do have and utilize what you do have in order to make the part. And I think you'll see after a while that it's not as difficult as you might make it out in your mind. You don't have to have a specific tool to do something. Make use of what you've got. Hopefully this helps. Sorry for the technical problem where the file got corrupted, but hopefully this will help explain how I made the holes in the plastic. Let's get back to the main video. Well, it took a little doing, but we got it done. Between this hole saw that I already had, and this is a 1.5-inch hole saw, and a step drill bit that I had, I was able to make the holes that will fit at the 9-foot level, the 18-foot level, and the 27-foot level. These are the 3 points where I decided to put the spacers and the guy lines. And this is right at where the joints are for the different sections of the pole, and it just worked out that way for 9, 18, and 27 feet. And I think that'll work fine. I've also made up some clips or clamps using heat shrink tubing to protect the pole and help it grip it as well for those different heights. Now we just need to label the different spacers here as to what band element is going through each of the holes. Now the 3 larger holes that you see on each of them is where the guy wires go. We'll orient these where they're the same. I'm going to start numbering them. That way we can it's easier to keep up with when you're threading the elements through the spacers. So I'm going to go ahead and do that, and then we'll come back and see that. Then we'll start making up the elements, the driven elements for the DX Commander clone. So stick with us, we'll be right back. Okay, we've got our pole laid out here in between 2 sawhorses. Got the base plates on, they're ready to go, and got the spacers made, drilled and marked where the different band elements are going to be. All 3 spacers are marked the same way to make it easier to thread the elements when we're ready to put them in. I've got the clamps made up, and we're going to mount this first one, show you how that is done. It's a really easy job, and let's go ahead and get started with that. Okay, going to take the clamp. The clamp needs to go on first, and then the standoff right behind it, the spacer. And we'll bring that down to the 9-foot joint where I decided to put it here. Got my clamp just a little too tight. Back it off a little bit. And I'll put the clamp right here above the joint. It doesn't have to be super tight. Just screwdriver handle tight, and don't really have to torque down on it. And then the standoff spacer just goes in right behind it, like so. So that's all there is to it. It's not hard at all. And we'll do the other two spacers the same way. Got the one for 18 feet and the one for 27 feet. So put the clamp on and then the spacer, run it down to the 18-foot level. And do the same thing, and that should be right here. And just tighten that down. Just snug it up. The clamp here it serves two purposes. One, it keeps the joint from collapsing, and the second purpose is it holds the standoff or the spacer in place, keeps it from sliding down. So let's go ahead and do the third one here, and we'll be through with the spacers. This one goes at 27-foot level right here, and it's smaller. It takes a smaller socket. Have to swap that out and just snug it down a little bit, and we're done. And here at the 27-foot level, we've got it in position now, and we're done with that. So now we just need to go make up our radiating elements, and hopefully I've got enough wire for that. I want to get this in position if I can, and at least get it guyed off at the lowest level today. I don't know if I've got enough paracord for that, so this is very much development on the fly, using most of the things that I already had on hand, and I did have to order a few things and waiting on those to come in. So let's get to making the elements. Okay, we're going to start making up some driven elements here. And let me take off my glasses, get the glare off, because I can see better close without them anyway. We're going to measure them out based on what Callum lists for the classic antenna. With one exception, we're going to make a 15-meter, dedicated 15-meter element also. So hopefully this will work out. I am going to leave them a couple of inches long, since this is not the exact same combination that Callum uses of band coverage. So I'm going to leave them a little bit long, just a couple of inches, and we'll see how that works out. If the frequencies are short, we'll find out that it wasn't necessary, and I'll have to trim it back some. We'll start with the 40-meter element, since it's the longest, and we need 36 feet 7 inches. 36 feet 7 inches. Now this table here is 5 feet long, and I'm going to be using that for my majority of my measurements, and then I'll have to use a tape measure to get down to the last few inches. But we're going to measure this on the table. Think if I can hold on to the wire. It's fighting me. This is 14 gauge THHN, and like with my other antennas, why am I using this? It's because that's what I have. There's 10. There's 15. There's 20. $25. $30. And there's 35. And we need 36. So there's, I got a foot marked out here. There's 36. And we need 7 inches. And I'm going to go ahead and make that 37 feet. And I know that's a little long, but it's easier to trim off than it is to add on. You can add on too, and we'll see if we have to do that or not. I'm going to use these ring terminals instead of the fork terminals. Why? It's because it's what I've got, and these fit over those bolts very well, so it's no big deal to me to use a ring terminal instead of the fork terminal. Cut off a little of the wire here, the insulation here. Put that in the ring terminal and crimp it down. Okay, I am going to solder. I'm also going to put heat shrink tubing on here. I think I'm going to cut off this yellow. Probably should have done that before I put the wire in it. That's going to get in the way of the heat shrink, so I'm just going to take that off. And the heat shrink will do the job that this was supposed to do and do it better. Alright, so there we go. I'm going to crimp that a little better there. Let's go ahead and solder that. Took a few tries, but finally got it stable where I can solder it. And see if we can get the old gun to work. Okay. Got the fan blowing over here, and I hope that's not too noisy. I don't know, but otherwise I couldn't make the video. It is 90, in the mid 90s here. The humidity outside is around 70 to 80%, and I can't stay out there in the heat in the afternoon very much. So I try to do the outside work in the morning before it heats up. Get some heat shrink here and get this thing insulated. Let's see what got some 4-to-1 marine with the glue inside of it. And I believe that's going to fit, but I should have put it on before I put the terminal on. Now I'm going to have to run it all the way from the far end. So remind me to put it on before I do the next one. but it just takes a few seconds here. We'll get it pulled through. And this wire here, it should handle QRO. I mean, this is 14 gauge, and it's more than sufficient. And that particular piece of heat shrink is not quite big enough. I thought it was. And let's see what the next size up is from this one. That's that one there, so this one back here should get it. Yep. So we'll put this one on. And this will just help protect against corrosion. I don't think we have to worry about it a whole lot since it's soldered. You know, with the solder being in there, it's not going to corrode between the wire and the terminal end there. All right, we got our heat gun, and you can use a match, you can use a lighter. This is I already had it, so if I've got it, I'm going to use it. But I also, I use matches a lot for this. If I'm not near a heat gun, I'll use a match or a lighter to melt it, and it does just as well. So, like I say, this is a 4-to-1 shrink, so it shrinks to 1/4 of its original size, and that's a good connector. Need to get a piece of painter's tape, which I think I have here, and we'll mark this as to what band this is for. Okay, found the roll of painter's tape, and use what you've got. Doesn't have to be this. I've also got a plastic label maker, but I think that's overkill, especially when we're starting out. Now, once I get the elements finalized, I may put that on there just to make it look good. But this is the 40-meter element. I'm going to write it on both sides so I can read it from either side. So we've got the 40-meter element cut, and we'll do the same thing for 20 meters. 20 meters, we need 16 feet 5 and 5/8 inches. Okay, I think we have enough of this one. We're not going to have a whole lot of elements out of this one. Then I'll have to go to the blue wire I've got over here. There's 5. $10. $15. And we need 16. So there's 16. And it says 5 and 5/8. I'm gonna do about 7 1/2. And I'm not gonna blame any of this on him, because I'm not following his instructions to the letter, because I'm not building exactly what he has. And his works. And if I have a problem with this, it's all on me. I'm not blaming anybody else. It's because I didn't think something through right, or didn't measure something right. But all right, we're going to get the heat shrink this time. Put it on here. Get the terminal. I'm going to go ahead and cut off this yellow, because it's just going to get in the way. That's why I should have my glasses on. All right. Got stripped off a little bit too much wire there. I'm going to trim that back, get it out of the way. All right, now I'm going to get this one soldered. Wants to fight me a little bit for some reason. Get a little solder on it there just to get the heat flowing, and then apply the solder to the opposite end. That way it'll draw the solder in to the joint, and we'll get a good electrical connection there. Okay, so that's crimped and soldered, and now we're ready to put the heat shrink on there. Run it out to the end. And shrink it on. All right. So that's the second one there. This is for 20 meters. Meters, 20 meters. All right, and we'll go through and do the rest. It's just going to be, you know, lather, rinse, repeat. We're going to be doing the same thing over and over. I'm going to cut them to length. I'm going to cut one for 17, 15, 12, and 10, and we should be good. When I come back, we'll be ready to install these on the antenna itself. Okay, you may remember that we marked the holes that we're going to run the elements through. I'm going to start with the 40 meter element, and it's this one here on the drive plate. So I'm going to take the bolt off and one of the washers and place that element on there, and just hand tighten it. We'll come back with a wrench later and tighten it. And we'll bring, this is the longest element, and I will need to put a tension loop in it after we get it run through before we tighten it up. So, but first we'll run the first through the 40 hole here. And the tension loop should go between this standoff and the next standoff. So I'm going to go ahead and run this through, and we'll come back and do the tension loop. Okay, the 40 meter element comes all the way to the top and will actually loop back. This is called the fold back. And we will have to adjust that as we go, tune it, but we can't do any tuning until we have all the elements in place, because they do interact with each other a little, but we have to allow for that. So we have to get all the elements in place before we can do any tuning. I may have to enlarge this hole here because that 40 element is going to have to loop back through. It could probably go on the outside there. I think that's what I'll do, is just leave it on the outside. But right now, we've got the 40 temporarily run through, and we'll do the 20 now the same way. And here's the 20. And I got ahead of myself. I had put the fold back tape on here, and that won't work because I have to run the wire through the standoffs before I can do the fold back. But I'm using Callum's specifications, and I accept full responsibility if this does not work right, because the gauge of the wire is different, and there's quite a few subtle differences about the way this thing is going to be put together, and I'll probably have to do some tweaking and tuning, but to me that's part of antenna building, so it is what it is. So we'll put the 20 meter wire over here. The same way we did the 40. And then we'll string it up through the standoffs like we did the 40. All right. But this one's not going to go all the way up like the 40, and there's where I had my bend. There's the 20 hole right there. I'm going to try to leave that bend where I had the fold back. And it's not even going to make it to the second one here at all. So I can put the tape back on here for the fold back. I'll do that. We'll do that all at the same time for right now. It's going to be interesting. This antenna is a little bit more involved. It's not really complex, but there's a lot of steps involved. And I got the same thing here. I did my fold back on this one too. Thinking I was saving some time, and actually wasted time. So having to undo what I did off camera yesterday afternoon late. Second guessing myself. Let's see, this one is 17. It's not the next one on the dial, but it's the next longest one, so I'm going to go ahead and run it. And since we've got all the positions marked, it doesn't really matter what sequence we do them in, as long as we match the sequence, you know, top to bottom. I'm really curious about this antenna. Got high hopes for it for DX, but it's unprecedented in my book, and this one's gonna be short as well. That's where the paracord and the bungees are going to come into play here. I'm going to let that one drop. And let's see, here's the 15 meter element. It's the next one on the dial here. And missing one washer off of that one. Again, this is all temporary because we've got to do tuning and various things. And here's another fold back that I got to undo. I try to, you know, I mess up from time to time. I miscount things. I make various small errors, and I try not to hide them from you. It's part of life. I ain't perfect. I don't think you're perfect either. But it's part of the process, and it is what it is. All right, here's 10 and 12. I ran out of the other wire, so I had to use blue wire. And this is the 12. You know, they get progressively shorter, as you should know. The higher the frequency, the shorter the antenna. And like I say, I am really, really curious about how this one's going to work. It's barely going to come through there, if it ends up once tuned, whether it's going to be all the way through there or not. We may have to make some adjustments, or make some accommodations for this wire, because the fold back just barely does come through there. And we've got one more for 10 meters. Wasted a little electrical tape. I left one washer off of that one too. All right, so there's no 10-meter element, and it shouldn't reach it at all. Okay, it'll be about a foot to 16 inches below this standoff. All right, we need to start using our bungees and paracord in order to start tensioning these up. And I think I'll start from the higher frequency bands to that'll put some tension on that on these two lower standoffs, and before I start putting tension on this end of the mast here, because it'll need support from the lower ones. So let's move the camera so we can see what we're doing a little better. Okay, I've got a couple of the bungees. I've got some paracord here, and let's see what we're going to have to do to get some tension on these things. And got my tape to do my fold backs. And let's start with this 12 meter right here. I'm going to tape it at the fold back length. And once we get tuned, I'll replace this tape with heat shrink. But while we're tuning and cutting and rigging here, tape is the more flexible and cheaper solution. So I need to run paracord from this up to the next support standoff up there. Just going to put a little square knot here. Like I say, this is temporary. It'll all be changed. And I'm going to cut this right here. Got to make sure and work it around my guy ropes here so don't get tangled on that. All right, this is 12. And let's see what we can do here. I'm going to have to run a little piece of this through the 12 hole here. And I think what I'm going to do is get my drill and a little bit larger bit and drill that out. Well, that wasn't much bigger. I thought it was a bigger bit. I need to get an even bigger bit. Bring out the whole arsenal this time. Maybe save myself a trip. I'm not going to go ahead and drill a 1/4 inch hole for this. For this paracord. A small piece through to hook the bungee to. Again, this is temporary. We're not going for neatness right now. We're going for functionality. And that should be sufficient there. Put a little loop. All right, put the little ball through there. Put this one through here. See how much stretch we got here. Pretty good bit. I'll stretch it about 80% or so. Put in a temporary knot here. And this is not going to look pretty. We're not going for pretty right now. We're going for functionality. And that 12-meter element is pretty taut. And we'll get another one on here and tighten it down the other way, and we should be good there. Let's look at the 15-meter, since it's almost 180 degrees out. And we'll do a similar thing there. Go ahead and tape the fold back here. Again, temporary. We'll put heat shrink on there once we're through with our tuning. I'm really curious how close this thing's going to be on first tune. I don't expect it to be super close. I intentionally cut the elements a little long since I'm not in what would be considered the normal configuration for this antenna. So I tried to make a few allowances, and that was one way I did it. Let's get the 15-meter hole here. Make it big enough to put the paracord through. Y'all can tell maybe this is the first time I've built this. I have not pre-built it, you know, and showing y'all second go around. This is first time. So let's get this down here. This is going to have to be a little bit longer since the 15-meter element is a little shorter. Okay. That's it there. We'll get a little through there like that and see how long this has to be. All right. And something like that should be long enough, because I'm going to pull it back and tighten it up. And it'll look much nicer when we get our shock cord and everything. All right. How much stretch have I got there? That's full stretch. I go about 80% stretch, and put a knot here. All right, so we've got our 12 and 15 tightened up, and let's see. Let's look at our 17 here, and it's coming up here. I think before I do the 17, I think I want to do the 10, just to try to even out the stress here. So I'll have to drill this one out, tape up my fold back there. So let me get the drill and the tape. Okay, and tie this one off. And we don't have, that's all of that cord. And here's a another red one. I've got two green ones. And, all right. So here's the tin. Let's tape the fold back on it. I can tell the closer I get on this thing, I'm getting a little excited. Although I don't have the radials laid out yet, but I'm still getting a little excited as to how this thing's going to look on the Nano VNA. I'm hopeful, but I do expect to have to do some tuning. All right, so we'll put this through like that. Put this through there. And I need to make that shorter. So I'll loop that through like that. That should maybe give me enough. All right. It's going to be all the way up. That's full stretch. That's about 80% stretch there. The humidity here, it's morning here in south central Kentucky. The temperature isn't bad. It's in the mid 70s, but so is the humidity. And you probably see me sweating a little bit. And also here in the cooler part of the day, the bugs are out. You may see me swatting from time to time. And that's these little gnats. Okay, so there's 10. So now we're ready for 17. And I'm gonna have to cut the end off of, we got a lot of extra on this cord that goes to this tree. I had 3 different bundles of cord that was all wrapped the same. None of them had lengths on them. And I understand why now, why the package didn't have any lengths. These must be seconds or whatever you call it, because none of the 3 bundles of paracord were the same length. This one was the longest. This one probably is closer to 100 feet, where the others were close to 50 feet. So let's see here. We've got the 17 and the 20. Let's see where the 20 is going to go to. The 20 is going to come up to here. So we need a short piece of paracord for it. And I don't think it'll be quite enough. Short piece of paracord for the 20, and I need to go ahead and tape the fold back on the 20 here. Need to roll this over so I can work on the 20 where it won't be interfered with. Get this 17 out of the way, and there's the 20. And we'll put it there. All right. Let's tape it. Okay. And we got another red bungee. This is going to look awful in the short term, but in the long term, I think it's going to be great. All right, we need about 3 or 4 foot piece of this, and need to drill a hole. The tools are always on the opposite side of where you need them, seems like. I spend a lot of my time walking around. And we'll drill out the 20-meter hole here. All right. And we'll need to make sure I'm not getting tangled up in my guy ropes there. Get on the proper side. All right, there and there. Don't need much, so I'll cut that about there. Try to, boy, this one's strong. Wow. I don't know what that's made out of, but I can't cut it with my knife. Let's see, let me get these diagonals here. See if I can get through it. Here's, barely nicked it. Yeah, the diagonals cut it. Wow, that was impressive, because I've been cutting the other stuff with my knife. All right. We'll go about 80% stretch on that. All right. So, looking good. What do we got loose here? Got the 40, of course, and what is this one? The 17. So we need to do the 17. Go ahead and tape it. All right, got the 17 and a bungee. And need to put a little of this down here as a standoff, because I don't want the bungee. And I'm not sure, I'm thinking that hook has metal in it, and I don't want it to detune by being too close to the element there. And we'll put a cut a section there. Put a loop here. Just simple stuff. Like I say, right now doesn't have to be pretty. And then I have to put another anchor. And I'm gonna have to untangle my guy. I'll have to I'll untie it here and straighten that out before we get through here. Drill out the hole for the 17 here. Alright, got that. I'll just cut it right here. And then we can tighten it as needed. Tie a knot. This outer coating on this is just super strong. I'm amazed how strong that is. All right, we've got, oops, what did I do? I must have collapsed a section here. Not that one, not that one, this one. Okay, kind of caught me by surprise. I don't have a clamp on each one of them, and I pulled a little too tight and it collapsed on me. So that is something I need to do, is get a clamp, or you can also put some electrical tape on each joint to help keep it from collapsing. And that should be sufficient tension on that. This bungee doesn't stretch very much. It only stretches about 4 or 5 inches. So I really just pulled on it too hard. All right. Now we got to work with the 40 here. I'm going to go ahead and untie this guy rope because I've got it out of sequence. It would have been tangled up with the elements. I wasn't careful when I was putting the elements on to keep it untangled, but that's good now. And we've got to go with the 40. Okay, we've got the 40 all the way up here, and let's rotate this a little bit to get the weight off of the 40, like so, so we can see what we're working with a little better. And it collapsed again. Okay, I'm gonna have to put a clamp on that to keep it from collapsing, I believe. So I'm going to rig up a clamp like we did on the others, put some heat shrink on there, put it on, and that should keep it from collapsing in the future. Okay, I had to end up putting 2 clamps on because the tension is causing the pole to collapse on itself. And I thought it might, but I was trying to see if I could get away without doing it. But on those lower sections, because we've got all these different bungees, even though each bungee's maybe only putting on 5 pounds of pressure, it's cumulative as we go around. Now, the only thing we've got left to do is snug up this 40 meter element, and it goes all the way to the top here and then loops back down. So I'm going to pull it here through the top and string it back down. It's not going to be super tight right now. I'll probably improve upon that once we do the tuning. But this fold back may need to be tuned quite a lot. I'm not sure. But we have all the elements on it. We've got the guy ropes on it, and we're ready to stand it up. Then once we stand it up, I'll need to lay out the radials. We've already got the radials made up and cut. They just need to be laid out. Let's see if we can stand this rascal up. I'm gonna get on the other side here where I can get to this guy rope that's going to this far tree and see how this thing looks. I'll need to move it just a little bit. And I may need to twist those spacers a little bit to make sure the elements are evenly spaced around the antenna. All right. And we've got this extra little piece of, I do need to get a wrench and tighten my elements down here at the connector plate, because we just made those finger tight a few minutes ago. But folks, it is up with some minor tweaking and laying out radials. We'll be ready to do some resonance and SWR testing here in a few minutes. So hang with us. We're going to get this done. Okay, we've got our wrench. It's going to tighten up the nuts on these radials. Want the terminal and wire on the outside here. That helps with the spacing. All right, good there. Do the same here. First one was 40. Let's see if this will work. No, I'm gonna sit down. Old folks can't squat. At least I can't. My knees don't work like that. We'll get all these tightened down, and then we'll start stringing the radials. I'm really curious as to what kind of readings we're going to get here. I expect it to be tuned low on the bands. I expect to have to shorten the driven elements. Like I said, I did that on purpose because it's somewhat easier to shorten than it is to lengthen. Guys, it's looking good. Ready to start putting on some of the radials. I brought a few of them out with me. There's going to be a total of 16 radials. So there'll be 4 coming off of each corner. There'll actually be 2 connectors, but a total of 4 radials. And they're not all made out of the same gauge wire, because I didn't have enough of any one gauge wire to make them all. And I've made a rat's nest here. Tangled them up, bringing them out here. There. All right, here's 2. And one 16 gauge, one 14 gauge. And I'll connect them to the same bolt here. And string them out. Connect them at 90-degree angles, thereabouts. and string them out. I don't know if these are going to stay. I'll probably have to rig something up to stake them down. Get these untangled. The wire has memory from being on that coil. All right, there's two of them. And they're going to relatively stay where I put them. And that's another curiosity for me, is how sensitive are they going to be to placement. And we'll do this. That one really coiled up. This one not, yeah, it's coiling up too. I'm gonna have to make some little stakes to stake them down. I can use some little bits of steel tie wire that I have. I can cut and make some staples and just staple the far ends of them right now and come back and do in the middle later. I'm going to get the rest of the radials and start laying them out. Okay, we've got our radials, all 16 of them connected. They're fairly equally distributed around it. Now all we got to do is connect the Coax and get the nano VNA and see what she looks like. But here it is. And I'm curious, really curious about what it's going to read. So let's get set up and do some measurements. We'll probably have to do some tuning too. I'm in the air-conditioned truck. The temperature is okay outside today. The humidity is horrendous. You would think, since we've not had any rain in quite a while, that the humidity wouldn't be this bad, but it is. And hopefully I've got the truck running. Hopefully it doesn't make too much noise. I've got the nano VNA here. Haven't connected it to the antenna yet. I'm going to do that now. I want to be I want my reaction to be real, which it will be, because I have not seen how this antenna resonates yet. So I'm going to aim the camera at the nano VNA. Let's turn it on and see where this thing resonates. Something's not right. Let's see here. Well, that makes sense, because I've got a Smith chart, I've got resistance, and I got log mag. I don't have SWR shown on here. So let me configure it here. I'll turn off. Let's see what traces we've got on. We've got the yellow trace on. Turn it off. We've got the blue trace on, which is a Smith. We'll turn it off. We've got the magenta trace on. We'll turn it off. So trace 2 must be SWR. Okay, so now we got some dips. Well, let's see where the dips are. You know, something I forgot to do that we will have to do, that 40 meter is supposed to have that strain relief loop above the second spacer there. So we're going to have to do that before we do any tuning there on 40 meters. So I'm going to lay the antenna down on the sawhorses again. We're going to have to make some adjustments. I'm going to use the calculator that Callum provides that should tell us very closely how much we need to take off to bring these into resonance. Be back in just a minute. We'll get set up to take the antenna down and do some tuning and see what we can do. I'm tickled that it's doing so well, even though it's just a little bit on the low side, which I expected because I made the elements a little long intentionally. I'm very happy for a first pass. This is what it is. It's close, well within tuning range. Let's see what we can do. Well, we're back at it today, and I want to try to save you time. I have wasted a lot of time chasing things that were incorrect. One thing I want to point out, you know, the scan that we did with the nano VNA from 1 to 30 megahertz, that gives you a good rough indication of where you're resonant. But as you've seen in one of my other videos where we talk about sweep points, the sweep points, it divides whatever frequency range you've got. I've got mine set up to 401, which is the maximum number of sweep points for my nano VNA. Well, for 401 or 400 into 29 megahertz, that makes pretty wide spaces between frequencies, and that's as close as it can get. So, you know, it's a nice chart to look at when you're scanning 1 to 30, but it's not one to tune by. I should have known better, and I didn't take that in consideration. When you come down to tuning, you need to use the specific band as the scan if you're going to be tuning for that band. So for, you know, 40 megahertz, you need to tune scan between 7 and 7.3, so forth, you know, across the bands. Scan each band and use that frequency to put into Callum's SWR calculator. His SWR calculator tells you what to trim or add depending on the frequency, but the frequency that you measure needs to be accurate, that you're inputting into this calculator. And I made the mistake, I should have known better, but I made the mistake of using the frequencies from the 1 to 30 megahertz scan, and that's not close enough, because some of these adjustments on these elements are very short. You know, you may need to add a centimeter or subtract 2.5 centimeters. And you need to be dead on the frequency that you input in order to get the result that you're wanting to get. So don't waste your time scanning 1 to 30 except just to look at a general overview. When you get down to tuning, scan the specific band. When you do scan your specific band, look at what frequency the antenna is resonant on. And, you know, we measure that by the lowest SWR. So look at that and then use that to put in to the calculator. Once you've measured all your bands and find out where it's resonant and get those frequencies, do not attempt to change both the fold back and the element length at the same time. You know, do one or the other. Don't try to do both. You can cut the element in two and either add or subtract there, leave the fold back alone, or you can adjust the fold back. Now, his calculator tells you what you can add or subtract from the fold back or add or subtract from the element. Don't try to second guess it. Do what it says. Either do the fold back or do the element. Don't try to change two at once, because they interact and you'll end up chasing your tail like I did. Should have known better. I should have known better. But in my hurry to get this antenna working and on the air, and Callum addresses it in one or more of his videos briefly, I'm putting a little more emphasis on it. Do one or the other. Don't change the element length and the fold back at the same time. You're going to get unpredictable results. Okay? So, enough said on that. Once you've made your adjustments, then remeasure. If you do like I recommend, you should be pretty dang close. Do one or the other. All right? We're going to remeasure the SWR on each band to find out where the resonant frequency is. We're going to put those numbers into the calculator, and then we're going to come back and adjust the elements. I wasted hours, literally hours. And I'm pretty sure that we do it this way this time, everything's going to be cool. So let's take some measurements, and then we'll make sure that this procedure works. Stay with us. Learn from my mistakes. That way saves you time. Okay, here we are scanning 40 meters, and you can see we're resonant way high on the band here, down near 7.3. So let's move the cursor down there and see where that is resonant. Okay, that's looking like 7.288. 7.288. So we'll record that, and then we'll go on up to the next band. Okay, here we are at 14, the 20 meter band, and we're resonant somewhere down here around 14,193, which isn't bad, but I want it closer to 14.2, 14.23, and so we're going to say it's resonant down at 14,193. Okay, here on 17 meter band, I had to open up the frequency a little bit to get a good look at where the dip occurred. But we're at 18,157, which is a little high on the band. I'd like it down around 18.12 or 18.13. So let's write this one down, 18,157. I had to do the same thing here to find out where it was resonant on 15 meters. And looks like we're resonant up at 21,583. 21,583. So we need to change that as well. Let's go on up to 12. And again here we're going to have to broaden our scan just a little bit, because it looks like we're resonant way down low in the band. Let's lower the start point down to 24.9. And it's pretty flat across there. Don't know exactly where the low point is, but it's somewhere about right there. We'll call that 24,935. Let's go on up to 10 meters. You can see the dip here is way down at the low end of the band, which that's not necessarily a bad thing, since we're going to have a sharp dip regardless of what part of the band we're in, and I operate primarily down here on the low end of the band. That may not be bad. We're at, I want to say that's 28,387. My eyes are playing tricks on me right now, but I think it's 28,387. You can probably see it better on the video because it's much larger. Those 8s and 0s look a lot alike on this display. So we're going to record that. That may be okay, you know, because I normally would operate close, you know, to 28.4. I may want to change that a little bit, but just barely. So let's put these numbers into the calculator and see what it tells us to change. Okay, I've got it pulled up on my cell phone here. This is m0mcx.co.uk. That is Callum's website, and he has an online calculator. And I put in our frequency that we measured on 40 meters at 7.288, and my target frequency is 7.2 megahertz. So I'm going to hit calculate, and it says we need to add, if we're going to adjust the quarter wave element, we need to add 11.7 centimeters. If we're tuning the fold back, as it says here, it would be twice that. I'm going to record both of those, and we're going to decide which one to do after we get the antenna down, okay? On this particular element, I think it's going to be easier to add it to the fold back. And that's probably what we will do here, because that's the one that goes all the way to the top of the mast and back down. So it's going to be easier to add it there. And I'll convert this to inches because I don't work in centimeters. I work in inches, and you probably do the same. But to convert it to inches, you divide the numbers he has here by 2.54. Divide by 2.54 because it's 2.54 centimeters per inch. All right, let's go to the 20 meter. The frequencies for the 20 meter, which was 14.193, and we want a target, at least I want a target of 14.23. Depending on where you want to operate, I operate in the voice portion of the band, so I want to tune closer to that. So 14.23 is what I want to tune for, and we'll hit calculate. And it says we need to cut 1.28 centimeters off the element. Okay. We don't have a lot of fold back on this one to cut from, so you know that's basically an inch off of the fold back. If we have an inch on that fold back to cut off, that would be the easiest thing to do. So we will look at that. It's easier to work from the fold back, you know, and if there's enough wire there to work from. If not, we will have to cut it from the element, which means we would cut the element in half, and then we'd have to splice it back together after we get through. And we'll go through that process. But when I'm writing them down, if I need to cut, I'm writing down a minus, and if I need to add, I'm writing down a plus, so I can keep up with what I need to do here. And this was targeted at 14.23. All right, and here we want to target for 17 meter. I'm going to say 18.12. It will be my target. You can, again, you pick the target you want. This is my target. We'll go back into the calculator here. This is just going to be repetitive, so I'm not going to show you each and every step. I'm going to do the calculations, then we'll go out and set up and actually modify the antenna. I think you'll be more interested in that. So I'm going to go through these same calculations for each of the bands, and I'll go over my targets and results later. Okay, here are the results of our calculations. On the top lines there, I've got it in centimeters, and right below it there, I've got it converted to inches. Some of these adjustments are relatively small, and I've decided there on 12 meters not to adjust it at all because it's close enough and it will tune in. And that one was relatively flat all the way across the band. So we're going to make these adjustments. And again, your results are going to be different, but I'm just showing you what my results are. And this was using the calculator on Callum's website, which does all the calculations for you. You put in your current resonant frequency and you put in your target frequency, and it tells you how much to adjust. So let's take down the antenna and we'll go do that. Okay, we're going to take down the antenna. I'm going to show you how easy it is to lower it here again, and then we'll get it set up on these sawhorses here, and we'll make the adjustments to the elements. Just loosen this one guy rope, walk it in, let it lean over slowly, catch it here with your hand, and the pole doesn't weigh much at all. The antenna and everything is probably less than 10 pounds, but it's just extended over such a length that you need to be careful with it a little bit. And there we are. So now we can start working on the elements. Okay, another thing that we've got now is our shock cord. So I'm going to go ahead and install shock cord and replace these bungees as we go. And since the first element we're going to work on is the 40 meter band, I'm going to tie into the tensioning loop that we created here and then tie it off up here to our spacer. So I'm just going to put a piece of it through, tie a little knot. All right, we'll bring it up here, and we're going to have to stretch it. I'm going to go ahead and cut it there for now. We'll run it through the same hole as the guy is going through. And this is supposedly 100% stretch shock cord. So that's about true. So we want to get somewhere 80 to 90% of the stretch, put tension on the element there. And we're going to do one of these double threaded knots where you just loop it through twice, and it should be big enough where it won't pull through the hole there. And that's going to work good. I think the hole there is a little bigger, so I'm going to double the knot again and make it just a little bit larger in diameter. There, I like that better. And that's putting tension on the lower portion of the element. I think that's going to work fine. And we'll cut off the excess here, so that won't be visible from the ground. Be a little nicer looking. Now I'm going to reposition the camera and we'll lengthen the 40 meter element. Okay, the calculation for the 40 meter element says the fold back needs to have 23.4 centimeters added to that, and that comes out to 9.2 inches. First thing I want to do, we need to cut the tape, and we need to add 9.2 inches to the fold back. You know, this is the fold back here. So to do that, I'm going to put a reference mark here on the fold back. And we'll put that reference mark 3 inches from the end. So 3 inches. Because we're going to have to trim back the insulation here in order to join the additional piece onto it, and we need to make sure to account for what is lost in the splice. So I'm going to strip this back to get down to the bare wire, and then we will add more wire to that and allow for this 3 inches. So our total length will be 12.2 inches from this mark. That accounts for this 3 inches that's currently there, plus the 9.2 we need to add. Went and got my wire strippers so we can strip off about 1 inch there. All right, so now we got bare wire there. So let's cut us a piece of wire. We need to add 9.2, so let's cut 11 inches and then we'll trim it to length once we get it spliced in. All right, there's 11 inches right there. Cut that off, and we'll see, we're going to have to remove about 1 inch of insulation from this one also to splice the two together. Then once we've got them spliced together, then we'll measure from our original mark to determine where to cut. We're going to cross them over in an X pattern and then wrap the ends around like so, which that's a strong splice. And I've got a piece of heat shrink here. I think this is large enough. If not, we'll get a different one. Yeah, this is going on. Get that over the end of it here. All right, so that's over that. And there's the torch there. And we'll go ahead and shrink the heat shrink. And there's our mark, so we're not covering up our mark. And it only takes a second with that torch to shrink the heat shrink. Now, we need to measure 12.2 inches from our mark. All right, because we used up some of that in the splice. So 12.2 inches. So right there, we should be good. Now we'll tape that back to the element. Tape the fold back to the element. I'm going to make sure this is pulled as tight as I can before I do that. Well, we've already got it taped up here. We're good. We're good. We'll tape that fold back here to the main element. And we should be tuned right at 7.2 megahertz now. Get this tape cut, get it started there. Now, hopefully if I did everything right, we should be tuned right at 7.2 megahertz for 40 meters. So let's go do the other bands, and then we'll get this thing up in the air and get it tested. Okay, I went through several iterations of the lengths on the different elements, and they do interact with each other somewhat. to me, it's not predictable as to how much they interact. But through persistence, I do have a nicely tuned multiband antenna. And you saw the process that I was going through, but I'm going to help you out a lot. I'm going to give you the lengths of the elements and the length of the foldback and the length of the tension loop. I think if you duplicate that with 14 gauge wire, you're going to be so close you probably won't have to touch it. In the description below, I'll give you a link to a PDF file that you can download and print, save you a lot of time and trouble. Like I said before, this antenna is not complex, but it takes a while to do the tuning. And Callum alluded to that in some of his videos. He said more than once, just cut it to the length that I've got in my table. Just cut it to that length. It'll save you some time. These lengths that I'm going to put in the table work. Now I'm going to show you the Nano VNA now, and it is, in my opinion, it's phenomenal for a multiband antenna without a tuner. No tuner is required. So let's look at it. Okay, here we are at 40 meters. Look at this graph here. On the high side down here, we're at 1.275 SWR. It goes all the way down to 1.0 here, and that's at approximately 7.23. There's 7.23. 1.01 SWR. Fantastic in my book. Let's go up to 14. On the high side down here, 1.49, and right here at 14,283, 1.125, and on the at 14,350, 1.25. Let's look at 17. Basically flat all the way across. I mean, that's great. At 1.33, it's pretty much flat all the way across. At 15 meters, down at 21.2, we're at 1.2. It bottoms out, well, it stays pretty much flat around 1.2 across there. And the high is 1.47. So fantastic there too. Here on 12 meters, 1.167 at 24,930. Pretty much flat. Goes up to 1.19 at 24,990. And here on 10 meters, you know, it's like it was. You can tune your dip wherever you want the dip to be. I prefer mine on the low side of the band. We're at 1.4, goes down to around 1.36. And on the high side, that's at 2.8. So even up here with your built-in tuner, you should be able to tune and work that band with no problems. You know, we've got 40 through 10 without any problem whatsoever, no tuner required. I think that's great. So let's get on the air. I don't know if this is a good time of day or not. It's in the afternoon. I don't even know what time it is. We'll see what it sounds like. It may not be the best time to work it. Probably need to come back out here at dusk and see if we can work the gray line, but I mean, this is looking great. This antenna is tuned. Okay, here is the completed antenna. All the temporary bungee cords are gone using shock cord. There we go, all the way up to 32 feet. It is looking good. It is working good. It is tuned good. Like I said, I'll have all the dimensions, links for the different elements in a PDF file down below. And good luck with your build. Okay, we've got the antenna connected to the radio now. I've already done a few QSOs, and I'm going to start recording and see what we can get here. Multiple bands are coming in. It's about, let's see, it's 2046 Zulu time. Not going to be the best band conditions, but we'll see what we can do. I'm running it straight into the radio. I don't have the SWR meter or the tuner in line now. Straight into the radio, and the SWR is fantastic. Of course, I can't measure it with just the radio, but what I measured with the SWR meter was fantastic. Let's see who we can pick up and maybe have a few QSOs.
Calling, go ahead.
Kilo Mike 4, Zulu Kilo Bravo.
Okay, there's two of you there, and I'll watch you both, and then we're going QRT. But Kilo Mike 4, Zulu Kilo Bravo, thanks for the call. My name is Gordon, located in Glasgow, and you're about 5 and 6, 5 and 7 with QSL.
QSL on the 5, 6, and 5, 7 from Glasgow, Scotland. I'm from Kentucky in the U.S. Kilo Mike 4, Zulu Kilo Bravo. I have you 5-9, 5-9 here in Kentucky.
Yeah, thanks so much for the 5-9, Jerry. You're at QSB there. You went down a bit, but good to hear you in Kentucky, USA. My pleasure to work you. Thanks so much for the call. Best 73. Bye-bye.
73s. Have a blessed day.
Bye-bye, 70. And the other station ended Tango Romeo. Tango Romeo, go ahead.
Okay, just talked to Scotland on 17 meters, so that's doing pretty good here at almost 4 p.m. Central Time. Let's see who else we can tune up.
You have a new friend in Mexico City. This is X-Ray Echo 1 Romeo Kilo. 73, Mr. Rogers.
Kilo Mike 4, Zulu Kilo Bravo. Kilo Mike 4, Zulu Kilo Bravo.
The Kilo Mike 4 again, please.
Kilo Mike 4, Zulu Kilo Bravo.
Roger. Thank you much for the call. I was going to take a cup of coffee, but before that, Jerry, let me say hello to you and give you a report from Franklin, Kentucky. You're picking 5 by 9 plus 5, Jerry. My name is Ralph, Romeo Alpha Lima Papa Hotel, located in Mexico City. How copy, Jerry? Over.
Oh, you're just a booming up here in Kentucky this afternoon. You're 5-9 plus here also. That's the reason I wanted to try to call to you. I'm just running 100 watts through a homemade DX Commander vertical antenna.
Okay, listen, your 100 watts at your antenna, Jerry. Listen this.
It's booming up here in Kentucky this afternoon. You're 5-9 plus here also. That's the reason I wanted to try to call to you. I'm just running 100 watts through a homemade DX Commander vertical antenna.
What about that, Jerry?
That sounds great. I really appreciate that, because I'm videotaping this. I'm going to be putting it onto YouTube on my YouTube channel here in a week or so.
Okay, my pleasure, Jerry. You do excellent with your 100 watts. Make sure. Thank you much, Mr. Duggan. Thanks for the gift. You have a new friend in Mexico City. So let me go to take my cup of coffee now. Best wishes. Have a great day, Jerry. Kilo Mike 4, Zulu Kilo Bravo in Franklin, Kentucky. This is X-Ray Echo 1 Radio Kilowatt in Mexico. 73, Jerry.
Thank you very much there, Ralph. X-Ray Echo 1 Romeo Kilo. This is Kilo Mike 4, Zulu Kilo Bravo. Hope you have a blessed evening.
Okay, 73.
Kilo Mike 4, Zulu Kilo Bravo.
Kilo Mike 4, Zulu Kilo Bravo, 59.
Copy the 5959 there. I've got you 5353 here in Kentucky. Come back with your call sign, please.
My call sign is Papa Yankee Alpha Mikey Foxtrot. Papa Yellow 5, Alpha Mikey Fox. Okay, Chloe, my name is Mikey Alpha Radio. Back to you.
Okay, having a little trouble on your call sign there. I got Alpha Mike Fox. Alpha Mike Fox. Come back with your entire call sign again, please.
Okay, Papa Yellow 5, Alpha Mikey Fox. Papa Yankee 5, Alpha Mikey Fox.
Okay, got you that time. Papa Yankee 5, Alpha Mike Fox, QSL.
Roger, Roger, Roger. Roger, Roger.
Appreciate it. You came up to a 5-5. I'll give you a 5-5 there. Appreciate the contact. Hope you have a blessed evening. 73s.
Okay, 73. Thank you for 5-5.
Okay. Getting some good QSOs here. It's working very well. I mean, with the conditions that we got. I've talked to Scotland. I've talked to Mexico City. And another country I've got to look up where they are. PY5 AMF. I'm not familiar with that, but doing very well. I need to put a grounding rod over here for lightning suppression. Give it a place to go. Hopefully it won't come in the house. Thanks for watching. This is Jerry, Kilo Mike 4, Zulu Kilo Bravo. Hope you have a blessed day.